Math 112ers. Sorry for the new face.
Hello.
We got Angel, Aaron, thanks for showing up face to face. I appreciate that. Nicholas, you go by Nicholas?
I
think that's
Nick or Nicholas, either way.
What was the other first one? Did you say Nico?
Nick or Nicholas.
Nick or Nicholas. Cool. I just graded your stuff, so that's all I know of you guys. So it's nice to meet you. Sorry for the interruption in service. I'll try to make this easy for you guys as much as I can. So you guys are a hair early, and so am I. But what I've been able to figure out from your syllabus and your online class, we're working on 6.5 and 7.1 this week in preparation for the test at the end of the week. But I also was kind of under the impression Matt had already talked to you guys about 6.5 and 7.1 a little bit. Can one of you enlighten me on that if you know?
He talked to us about it a little bit, but I think he said he wanted to go over some of it a little bit more. So looking at the notes, just a second.
Yeah.
Yeah, he kind of said that 7.1, when we cover it, will be a lot of review of what we've already done, but he didn't go into specifics.
Yeah. Well, the assignment, the paper assignment, which I think is the only one he's given you guys that you did that I graded for you guys the other day, that has a lot of 7.1 on it. And I just found myself not totally clear what you guys had covered because the last few questions on it are kind of those hard, ugly trig solving questions that probably made you hate math. So you got to have some instruction to be able to solve those dumb things. So.
Yeah, I was a little confused on that too, like where we were at, because I don't know, the syllabus was different for the test. So I finished 6.5 and 7.1 kind of sooner than it was due because I thought we were having the test on Friday. So I was a little confused over the quiz and what we were going over in class also. So I don't know, but I'm very easily confused in this class. Me. So.
That doesn't make you a bad person. I understand that. Well, anyway, my name is Doug Gardner. I am both the department chair and I've taught math for approaching 30 years now, and I unaccountably still think this stuff is awesome, which is embarrassing and awesome all rolled into one. I draw house plans and do construction on the side. So my largest enjoyment of math is what it can do. I'm not near as theoretical as Matt is. I'm sure this class is going to feel a lot different in the way that I'm teaching it and testing and so forth than what Matt did. But I'm a very practical minded person. I like what you can actually do with math. I like the applications of it and so forth, more than I like the theory of it. So one of the things I want you to hit me back with, right away via email and so forth. Oh, you guys froze. That's not good.
Oh, you're back.
Yeah, I saw you guys freeze.
And he's gone again.
Okay, it looks like we're back. I see you guys. I really appreciate you guys showing up face to face because I have had occasional internet issues here, but it looks like we're okay now. If I see you freeze, I'm going to stop talking and wait till you start moving again. So, let me see.
We might just be staring in disbelief. It's fine.
At least you'll be frowning. That's what I'm really looking for is frowns. If I see frowns, I know that we're making some progress. So I've went in here and kind of fixed the, and by the way, nothing's wrong with Matt. He's just got some things he's got to figure out. So you're more than welcome to email him if you want to ask him any questions. But he's okay. He's not in the hospital or anything. So I went in here and updated this calendar. So yeah, we're essentially, I really am thinking of us as getting ready for Friday's test, which I went in and sort of made today. And I really just picked, and I assume you kind of have this all figured out, but I want to give you a chance to weigh in on it. But I really just went into your homework assignment from all of chapter 6 and 7.1 and looked at what I consider to be the most important questions on there, and effectively chose some of those in my open math. And as before, you're just going to have one try. They're going to be homework really similar to your homework questions, but obviously want all your scratch work, both because I want to see that you did it, but more importantly than that, because I want to give you partial credit if you did something wrong. Because that's the one frustrating thing about my open math. If you got something wrong and the only reason it's wrong is because you did something dumb, which you're going to watch me do lots of times as I'm teaching you things. A student in my calculus class today, had 4 squared, but they wrote 8, because 4 times 2 is 8. And that's the only reason they got it wrong. Well, in my opinion, in math, it's as hard as calculus, or even as hard as what you guys are doing. If you make a mistake of that nature, you shouldn't be docked very many points. So I want to see that. So make your work as clear as you can. So that test will pop open for you at 8 o'clock Friday morning, and then you'll have like all day Friday, not all day to do it. You have like I forgot how much time I put in there, but I'll try to make sure that's enough time, because I really like people to be able to check their work and so forth. So you'll have whatever, an hour to take the test, but you can kind of take it whenever you want to. So maybe that makes it easier for you convenience wise, because you got some other schedule. So feel free to ask me those kind of things. Anyway, to clean this up, and I actually am willing to adjust this. The 2 homeworks, 6.5 and 7.1, that still aren't due are due today and then Thursday. And obviously it doesn't really do any good to make those due later, because you need to practice them for the test on Friday. But for the most part, all the other stuff is due Sunday. In other words, we'll talk next week. We'll talk about the first part of chapter 7. That's where there's nothing due. And then that homework is due the following Sunday night. When I got in here, everything was due like the 28th, like the whole rest of the class was due on the 28th, which didn't make any sense. So that's all kind of fixed to take us through the end of the year. This is the last week of class, if I remember right. So yeah, so our last day of class is the 24th. So that day you'll be taking the final exam. So we'll review on Monday and then take the test on Wednesday, the final test. Are we cool? Like you feel like you understand what's going on as far as what was already happening in there? And does that all make sense to you now? So effectively this week we'll be talking about, I think, 7.2 and 7.3, and then there's its assignment. Then this week we'll be talking about, I think, the first part of chapter 8, and then there's its assignment, and then this is the last part of chapter 8, and then the test. So cool. And if you haven't already figured it out, these information about test links are worthless, because they're like when we used to take things in class, so there's nothing in there helpful to you. Right now I can't, because we had some kind of a software or some kind of a virus at our school. I can't get to my school junk, but what I'd like to do is I'd like to put some practice questions in here for these tests, because I make big reviews that I kind of hand solve myself, because really there's nothing in here for review. So I'm, at least as far as this week, I'm really looking for the 2 days we get together on Monday and Wednesday, just to be a chance to make sure you know what the heck you're doing before the test comes.
There's
So
a-
I have a question about the test, mostly just about what problems on our homework you deemed to be important.
Yeah, no, it's a great question. And I think it's very much my job to make sure you know, like, this isn't a trick. So let's make sure we talk about that tonight and on Wednesday. And if I can get back to my school site, I'll even post some of that. And there was one other question.
Sorry. There are reviews, but they're way longer than the test would actually be, which doesn't really give me an insight of how, like, what's the most important and what's not. So
Fair
there's
enough.
also reviews.
Where
case
are
you were
those?
wondering.
Where are those reviews? I never found them.
They're always on the last week before the test. So for example, like week 6, there's a review in that
Oh, okay.
section.
In that folder.
Right at the bottom.
Oh,
right
yeah.
at the bottom.
Okay, sweet. Okay.
Like 34 questions or something. I was still working my way through it.
Yeah, and there was like 10 questions in the first exam, so I was like, oh great.
Yeah, and that's not a bad plan for a teacher to give, you know, a number of review questions just so you, but yeah, to limit it down a little bit. To do a good job teaching, you don't want students to just be able to practice and then copy something exactly the same on the test. That doesn't necessarily demonstrate understanding, but neither do you want to give them problems that are so much harder they get lost. So so since you all asked, Madeline in particular, because you asked this question, I'm going to stare at this right now and like tell you right now live, just looking at this. I think it's really cool, and we'll do some application problems in a few minutes from 6.5 about being able to you know, take a graph that looks like this and find its equation. And y'all are aware you get the note sheet, right, for this. You'll have that on the test. Do you know that automatically? Do you know that already?
Yes, I have mine printed out.
Yeah, and I would print it out if you haven't already done that, because that's kind of a big part of this class. And we make a ton of use of that. For those of you who have to go on to calculus, we make a ton of use of that. We end up looking back at it all the time. So that's a good thing to print out. So the fact that, you know, there's a period and amplitude and a phase shift to this, and, you know, which one went where, you know, like you should be able to look that up on that note sheet. So we'll talk about that with an exam. So you're going to see a question like that for sure, where I give you a graph and say, what's the equation for this? And of course, you have your graphing calculator. So, you know, one of the things I love to see in notes as a teacher is, hey, I know this is wrong. And not only that, I know which one's wrong, but I don't know why. Like, if whatever you type in for an answer for a graph, let's pick this example, because here they're basically asking you to give me the full equation. You can type that into your graphing calculator and see if it looks like the blue graph there. And if it doesn't, you know you're wrong. And it's even cool if you, not only that, but you can tell what's wrong. Like, hey, the amplitude's too tall, so my amplitude's wrong, but I don't know why. I mean, I love notes like that. Because in the real world, when you know you're wrong, then you don't go build the house. You call someone and say, I'm wrong. I don't know what's wrong. Like, help me out. So I can give more partial credit when you know you're wrong because you checked your work than if you have no idea that you're wrong, if that makes sense. So out loud, I like all these questions. You know, can you look at this and tell what the amplitude period and vertical shift or midline is? Can you tell what those are? Because that's what it takes to find an equation for it. That's kind of that's the go-between between the graph and the equation. And then if you're given an equation, do you have a feel for what this is going to look like? You know what a sine wave looks like? And do you know that 4 is the amplitude? So it's going to be 4 times taller than usual. And 2 has to do with the period, although it's not the period. So it's going to change kind of how quickly the thing bounces back and forth. And then 8 is going to slide it left and right. And 3 is going to slide it up and down. Do you have a sense of that with that note sheet? Are you able to say, oh yeah, I can totally nail, you know, the period and phase shift and amplitude from all of those things? I like all those questions. This one, you're actually making the graph yourself. So what I'm going to do is tell you things that I don't think are worth doing. I'll tell you now, I'm not going to give you any graphs that aren't sine and cosine. I'm not going to give you tangent, secant, cosecant, all those. Not that that doesn't occasionally come up in the real world, but that's really rare that that's useful. Are you celebrating, Madeline, or stretching?
I was celebrating, yes.
My philosophy test-wise is that homework should include questions that really push you and challenge you, but a test ought to be a fastball right down the middle of the plate. If you've practiced and you know the stuff, you should be able to get a good grade on the test. So that's why those are getting left out. So all those questions, where did that start? Question 8, question 9, question 10, question 11. Not going to see those. You might see these. These are good. Are you looking on the unit circle to determine that? In other words, one of the things I hope stands out to you is if I said something like inverse sine of 0.3, then you should say, oh, I got to have a calculator for that. But whenever you see square root of 3/2, 1/2, do those stand out to you as like, oh, those were some of those exact ones? and I've taught this for 30 years and I don't remember what they are. Like I can make them for myself, but I don't have them memorized, which is probably a little embarrassing. I shouldn't admit that. But I know those are exact ones and I could rebuild it if I have to, but if you let me, I'm going to look it up. So the fact that, oh, these probably have exact angles. One of the things I find in calculus that students don't understand very well, but if you take the inverse sine of it, then that's two sides of a right triangle. Do you understand that? Sine is opposite over hypotenuse. And so, hey, the opposite is the square root of 3 and the adjacent is 2. I'm sorry, opposite and hypotenuse. The opposite is square root of 3 and the hypotenuse is 2. And so I could actually draw a picture of that. And so what this is giving me is the angle in the right triangle. And so because I recognize that, I know that the angle's, you know, a perfect one. It's 30 or pi over 6. It's exact. It isn't some calculator type of an answer. So being able to use your cheat sheet, that should, those, I hope you look at those and say, oh, that's totally easy. I can just look that up on that sheet. Do you have memorized that sine is the y coordinate of that point and cosine is the x coordinate? And even better, do you have it better than memorized in the sense that sine is opposite over hypotenuse? And so opposite would be a y value on the unit circle. I need to start drawing pictures of this, but so these questions are good. We're actually using inverse tangent. In other words, up here, you're being just told, hey, go find the inverse cosine of the square root of 2 over 2. But down here, you're just given a triangle and you'll have to use inverse tangent or inverse sine to be able to figure out a missing angle. I use that a ton in construction, by the way, and save myself lots of money and time and get stuff exactly right as a result of that, which is really cool. And then, you know, here's an example of a somewhat practical question. So yeah, the rest of these are all a thing. I don't know, how ugly is that to you? Sine of the inverse.
Very. I hate it when the sine and cosines are like together like that.
Yeah.
Hate it. It's the worst.
Yeah, that's probably painful. So let's go take a look at something like that right now. So I'd say most of everything else, I don't like these Ferris wheel questions, but I like this temperature one. So there's a hint. Because I think they really model something. But I'd say most of the rest of that stuff is worth practicing. I probably won't give an equation solving problem that's quite as ugly as this one. But you will see something like this, sine squared minus sine of x minus 1 equals 0, something like that. So armed with that, I'd like, you know, over the next couple of days, I'd like your questions to drive what we talk about a little bit, because really at this point we're kind of in test prep mode, and you'll do better on the test if we talk about things that you see on that review right there that make you struggle. So the other thing I will do is I am recording this Zoom session, and I'm also, when I write, I'm going to post what I write. So I got rid of it, but I put a file, I renamed a file that Matt in here, was called videos, but I called it videos and notes. And so every day after we get done, I'm gonna post that video, YouTube video of whatever we talk about that day, so you can go back and look at it, or if you miss a class. And I'm also gonna post what I write down. And I tell you that because I'm extremely interested that you are present and not just writing stuff down. If I'm writing it down, you don't need to write it down. Therefore, you can be with me and I can ask you questions and you can think. Trig is really easy if you can see that it's just SOHCAHTOA, and I'll show you that right now. So I'm going to share a screen. I'm so glad the internet is working good now. Yeah, here we go. So I'm going to say this is test review, even though it's really kind of more than that. I'm going to go back and steal that question. And did I get rid of that? Where did it go? Where did that go? Where is that ugliness? Cosine of the, I'm about to give up. Come on, where was it? There it is. Sine of the inverse. Sine of the inverse cosine. What a ridiculous. Okay, you can see my screen again, right? So let me ask you a question. Why is that impossible? Ignore the sign out front. Why is the inverse cosine of 5/2 impossible? Can somebody tell me?
Greater than 1.
What does that look like in a right triangle?
A line?
Really dumb.
So this entire class is SOHCAHTOA. Like you can understand and have this in your mind. The only thing that causes people trouble in calculus is they were in algebra, but that was like 2 months ago, and now they've kind of forgotten it. You got to learn how to see that this is super easy. The only thing you have to memorize is SOHCAHTOA, which tells you which sides are which. In other words, if we're talking about cosine and it's inverse cosine, that means this 5/2 is not an angle, it's a couple of sides in a triangle. And because cosine is adjacent over hypotenuse, then this is code for 5 is the adjacent and 2 is the hypotenuse. Do you have that aboard in your brain at this point in the class? My experience is not really most of the time, because I think you got to learn how to think about this. So what we're talking about.
Yeah, no, I don't look at a fraction and automatically go adjacent over hypotenuse.
And you should, because there's a cosine in
In
front
my
of it.
mind.
That's kind of that's what I want you to understand. So trig only applies to right triangles. And what we're after is that angle right there, one angle. It doesn't have to be that one. It could have been the one on the top. But because cosine is adjacent over hypotenuse, then 5 is the adjacent and 2 is the hypotenuse. And that's why it's impossible. Doesn't the hypotenuse have to be bigger? There's no way the hypotenuse cannot be the biggest side of a triangle. So that makes no sense. It's not just because, as a math teacher would say, 5/2 is bigger than 1, and that's outside the domain of inverse cosine. That's a too confusing way to understand this. Draw pictures of it. It's right triangles. It's not that complicated. So that's impossible. Okay, well, let's go do the actual problem that was in the book then, which is when they did not flip this upside down. So that is fine, because now the 2 is the adjacent and 5 is the hypotenuse. The key is, do you understand when you take inverse cosine, that you are, I guess I'll say, angle hunting? You're trying to figure an angle out. That's why you do it. And again, that's going to be a question on the test right there. In other words, you're going to be given a picture that looks like this, and you're going to be asked to find the angle. And so you should look at that and say, well, I know that 2 is the adjacent and 5 is the hypotenuse, and that's cosine because of SOHCAHTOA. So the cosine of theta equals 2/5. And then you're going to say, okay, now I know how to get rid of cosine. I have to take the inverse cosine. And to me, that's a more natural question. Does it make sense? You're probably going to get that right more than this ugly statement that you were given. But my concern is, when you stare at this statement, do you just go, that's easy. That's just right triangles, and 2 and 5 are a couple of the sides. And so that's going to produce this angle. That's the key, is it's producing an angle. Okay, well, if that's true, then what's the sine of that angle? Since this whole thing here, this whole piece of beauty is really just an angle, then what's the sine of the angle? Well, what does SOHCAHTOA say? What is sine?
Opposite hypotenuse.
Opposite and hypotenuse. Well, isn't this the opposite, which I don't know? But how can you figure that out?
Pythagorean theorem.
Yeah, super easy to figure out with Pythagorean theorem. So since that side, because of Pythagorean theorem, would be 5 squared minus 2 squared, which is 25 minus 4, which is 21. Then that side over there is really the square root of 21, which I'll add to this now. And so now can't you answer the sine of the angle? Like, even though you didn't figure out what the angle was, although you're more than welcome to get your calculator out and go inverse cosine of 2/5 and get the angle, you don't even have to know what the angle is to figure out what the sine of it is. Since sine is opposite over hypotenuse, it'd be the square root of 21/5. So that's the ultimate answer to this ludicrous statement that only a mathematician could make up. You will never, no one will ever ask you that in the real world. But
And if you did use your calculator for the angle, it wouldn't give you an exact number. Most of the
Right.
time you want to give the exact possible.
Yeah, so if my open math or the nerdy math teacher wanted an exact answer to that, then you wouldn't get it by punching calculator buttons. But in the real world, you could totally punch calculator buttons and get that. Go inverse cosine of 2/5, get an angle, and then take the sine of that angle. It's just that you're going to get a decimal out. Nobody's going to look at that decimal in their calculator and go, isn't that the square root of 21/5? I think I recognize that. Like, you're never going to recognize it, but it doesn't make it wrong. So if I'm you and the My Open Math or the test question that I write to you doesn't say give it exactly right, then you can kind of cheat on a technicality and get it right. But I'd argue that's more work, I guess is what I'm saying. So let me ask you this question then, similar to that. It's not going to work. I got to change this a little bit. Let's take the, we already did sine. Let's do cosine. So the reason I gave you this is this might bother some of you. Why is this different than the last problem?
It's not a fraction.
It's not a fraction. Thanks for reading my very small mind, Madeline. That is not a fraction. But yes, it is. You just have to make it one. Still a fraction, isn't it? There's no such thing as a number that isn't a
Would
fraction.
you just put it over 1?
Exactly right. So if you're given some weird statement like the square root of 2, it's still a fraction. It's just 4/1. And since tangent, I'll do this quickly, kind of for you. Since tangent is opposite over, and I'm even going to draw the triangle different this time. What if we're hunting for this angle up here? It doesn't matter what angle you pick. It's like that angle. Well, tangent is, as you know, opposite over adjacent. If the teacher did not let you have notes, the only thing you memorize outside the door before you walk in is SOHCAHTOA. And then you walk in and don't let anybody talk to you and they hand you the test and you write down SOHCAHTOA. And then you should be able to get everything else right. And that's all you know. Tangent is opposite over adjacent. That's got to be memorized. There's no way around that. So that means if this is the angle, then isn't the opposite 4 in the adjacent 1? Now I know 2 sides of the right triangle, and now I know everything I need. If you know 2 sides, you know all sides. 4 squared is 16, 1 squared is 1. When I add 16 and 1, I get 17. So this side's the square root of 17. So now I know all the sides, right? And so since this whole thing is just code for find theta, then can't you now find the cosine of theta? I mean, that's actually faster than punching calculator buttons for what it's worth. Not that this is a race. So what 2 sides is cosine?
It's adjacent over hypotenuse.
Adjacent over hypotenuse. So relative to this angle, isn't this side the adjacent and that side the hypotenuse? So the cosine of the angle would be 1 over the square root of 17. For my class, you're done. Some teachers don't like the square root on the bottom, and I get that, and I'm not going to go into why, but you should be capable of if some book asks you to rationalize the denominator in the language of mathematics, and they want you to get rid of that square root, you should be capable of doing it, but don't do it if no one makes you, is my attitude. I'm not doing it if no one makes me. So those statements look weird, but they're not. They're super easy.
Could you show
So
us
it-
how to do that?
One more time.
Show us how to do the rationalization.
Yeah, so for me, you're done. You don't have to go any further. It would involve multiplying the top and the bottom by the square root of 17. So those aren't hard if you understand what they're saying and how simple what they're actually asking you to do is. Let's see. So I was about to do one other thing, but is there something else on that review that bugged you? I mean, I just zipped through it and I don't want to bring it back because I just want to leave this note sheet up. But is there any other type of questions that you've seen over the course of this, you know, particularly the most recent stuff, 6.5 and 7.1, but things of this nature? I mean, that's an example of a problem that this is going to be really hard unless you understand what it's saying.
Yeah, I have problems with reading graphs and then like being able to get an equation from the graph.
Mm-hmm.
Can we run over that as a class?
Yeah, so let's do this in the form of an application. So let's make it even harder. Actually, I'll do something that's even a little more. Now let's start with something easy. You have an assignment question that deals with temperature. What trig graphs do a really good job of is modeling things that just oscillate back and forth, like they go up to a high and then they go down to a low and they go up to a high and down to a low. And can you appreciate there's actually quite a few things in your life that would actually do that? Like medically, you probably have like a sugar level that goes up in the day when you're eating, or you eat something and then your sugar level ramps up and it's really high. If you're diabetic, this is probably something that would be concern to you, or you're a doctor and you're helping people that are. Ramps up to something really high and then you stop eating and then it levels back off again and it gets really low and then you start to tank. And then you eat something and it goes back up again. And so that'd be an example of something that goes up and down. Something that's a little near and dear to me, because I love to be outside, is minutes of daylight. Are you familiar with what summer solstice is? What summer solstice? June?
It's the longest amount of daylight in the year.
It's the most
right?
minutes of daylight in the year. Summer solstice, June 21st. And so that's the highest minutes of daylight. And then December 21st, if I remember right, is the lowest, but then doesn't just repeat next year. It's the same exact thing. There's like the highest minutes of daylight, the lowest minutes of daylight. So I'm hating it personally when it's December 21st, because that's like the dark the most and I can't get outside. And but again, a trig equation will model that really well. And so you can actually predict the future. That's what trig's really about. So let's try this. Let's say that in temperatures like that, right? Like on a given day, it gets the warmest, let's say at 2 p.m., it's the hottest. And we'll say it's, I don't know, 88 degrees. And then we'll just say that the low is, I don't know, let's say 40 degrees. And so let's just say, it's about, you're in Arizona or whatever, and it just kind of does that for 2 or 3 days. Now, the temperature changes. And so that sine wave is actually going to, move down or go up and so forth. But at least for a couple of days, it's a reasonable illustration. So I'm going to give you a second. Can you draw like a rough sketch of what that would look like on a piece of graph paper? And let's say this is 0 o'clock or like midnight. In other words. So let's see, 12 hours, 24 hours, that'd be 18 hours, that'd be 6 hours, something like that. And our high temperature is 88. So I could put 88 up here, and then I could put low temperature of 40 down here. And so is that graph going to kind of, at very least, to start out simple, isn't that graph going to kind of oscillate like this? Can you see why that would be a sine wave? Now, I made it oscillate way too fast. Maybe that would be what it did over the course of like 3 days. But the point is it's just going to bounce off of 88 and 40, right? It's going to hit 40, go back up, hit 88, go back down. Now I just got to do a little better than that, right? I got to be a little more precise. How do I get that involved?
Assuming the graph starts at midnight or like whatever the 0 would be, shift it to the right 2 hours. That's where it would start.
Yeah.
And then it's hottest, and so it's negative sign.
Yeah. And you're sharp enough that you're getting a little ahead. Even going 2 hours past noon and saying that point right there, somewhere around there, that needs to be on the graph and it's going to be a high point. Does that make sense? You're even jumping ahead of that, Nicholas. And so that's going to be a high point. It's going to turn around right there. So what's the period of this graph? Like, how's this repeating itself if this is kind of repeating itself daily? How much time does it take for this to repeat itself? 'Cause that's
Would
kind of
be
implied here.
24 hours.
Yeah, I would need to say that in the problem, but does it make sense? A tide would do that too. You'd have high tide and low tide. It would repeat itself every 24 hours. So I would need to say that in this problem if it was on the assignment, I think, but I guess you could assume it here. It's repeating itself in 24 hours, which basically means if it's there at, I guess, since that's 2 hours past, you military people would call that 1400 hours at 14 o'clock. Does it make sense? It's going to be up to that again. Now it's going to go off my graph. I probably should have made my graph a little bit bigger, but it's going to be out there again, peaked out here 24 hours later. So since this is 14, if I add 24 to that, I get up to 38. So at hour 38, it's going to be back up there again. Does that make sense? And of course, that also means then that half of that would be 12. That statement makes no sense. Half of 24 would be 12, but half is 12. So does it, and then I think was what Nicholas was getting at. Does it make sense that it would be at its low 12 hours before that? So at 2? In other words, this graph is kind of doing this. I now think I understand roughly what this graph looks like. I think it's doing this. I think it's kind of going up here, hitting this, going back down. Would you agree that's at least a reasonable rough graph of this? You should, unless you're really sharp, kind of have to draw that out a little bit before you can survive finding an equation for this, I think. The important thing is to understand that I need to know kind of 4 things about this graph in order to be able to find its equation. I got to know the period. I've got to know the amplitude. What was Matt calling the, how much the graph shifted up? I forgot what your book called it. It called it the...
Oh, he just called it the amplitude.
Well, the amplitude is how far it kind of, the ocean goes higher.
Oh, then I think you're talking about the phase shift.
Yeah, there's some books call it the vertical shift. I just don't think your book called it that. Because that's really like how far did the graph slide up? The phase shift, and that's actually coming from electricity, which is an amazing another application to this. Do you know that your house has AC electricity, alternating current, which basically means electrons are getting pushed and they're coming back and they're pushing, and they cycle at 60 hertz, 60 cycles a second. Like that's why you have electricity in your house. So electricity is another amazing application for this. But phase shift is really code for horizontal shift. Those are the 4 things we got to figure out to find the equation. They're the middleman between the equation and the graph. So really the first one you need to figure out is actually this middle one right here. Which one of those 4 is that middle one concerned with?
Amplitude.
Partially amplitude, but I'm saying specifically this distance. Do you agree that normally,
Right then.
Vertical shift.
Yeah, normally sine and cosine waves oscillate along 0. They oscillate along the x-axis, but this one's been moved way up. So I just remembered what your book called it. It called it a midline. This midline is usually the x-axis, but our midline is now up here. So that really is concerned with the vertical shift, which I heard one of you say. I was looking down and see who. So how much did that shift? Well, it used to be at 0, but where did it go now? Notice you got to figure that out for yourself. What's halfway between 40 and 88? The best way is just to reason that out for yourself. Like sit there and play around with it.
48.
If you're a formula related person, you take the average of them, add them up, divide by 2. But I find myself not thinking of that. Even though I'm a math nerd, I find myself just thinking, well, what number is halfway between there? And I might throw out a number like 48. And then I think, let's see, that's only 8 up, and that's way more than 8. So it's not 48. So it's 48 between them. So half of that would be 24. So that means I got to go up 24. Do you agree with that? Up 24 from there. So that puts me at 68. I can't add. That's 64. That's what I was talking about earlier. So if I go 24 above that, does it get me up to 88? Yeah, it does. Okay, so do you agree that 64 is the midline here of this? So that's your vertical shift, 64. So this thing went up 64. Now in this context, what does that mean in this context? Given that we're talking about really time.
The median temperature of the day is going to be 64 degrees.
That's exactly right. It's kind of like the average temperature for the day. And the temperature goes up in the hotter parts of the day and down in the colder parts of the day. In other words, it oscillates away from that. So that's what I like to think of as like calm seas. I mean, see these as ocean waves. If there's no wind, then 64 is the depth of the ocean here, so to speak. 64 is the temperature. So I now know that. That's cool. And now knowing that, now I can figure out, and we just did this a minute ago, but I can actually figure out the amplitude. The amplitude is not the distance all the way from the top to the bottom. It's from calm seas up. That 24 that we just found a minute ago, that's the amplitude. Again, look at your note sheet so that your note sheet is speaking to you. You don't want to have to memorize this stuff. So amplitude is how far is it from calm seas? It's 24 up and 24 down. It's not 48. 48 is the total distance between them. And by the way, there's no reason it has to be that way. If somebody wanted to call the amplitude the distance from the bottom of a wave to the top of the wave and it was 48, somebody wanted to define that as the amplitude, they could. So I've figured out lots of key numbers now. So maybe you know lots of things about this equation then, like where does the amplitude go? You can look at your note sheet. What do I do with that 24? Where does it
Put it
go?
in the front.
It goes in the front. It's that front number. And by the way, that's probably why people chose to call that the amplitude. If the amplitude was the distance from the bottom of the trough to the top, 48, then you'd actually have to divide it in half. So it's really cool that you can just take the amplitude off of the graph, which is the distance from average to the high temperature, the distance from average to the low temperature, and you can just throw it straight into the graph. That's really cool. What about the 64? Where does it go?
Added to the end of the equation after cosine.
Couldn't be said any better than that. Just added to the end. And if you think about it, that makes sense because what are you really doing? You're adding 64 to every y value. Before, when this graph was down here, if you just said, hey, take every y value and add 64 to it, isn't that just going to move the whole thing up 64? Like this stuff, you don't have to just memorize this. It makes sense. Those are the two easiest ones. Now, the period's a little bit tougher because the period is 24 hours, but there's no, and that's sort of I picked a bad example because unfortunately we already have 24 in here for another reason, but 24 does not go in here anywhere. What do you got to do to 24 to stick something in this equation? Again, look at your note sheet so that it's speaking to you so you can get this problem right on the test. What do you got to do to 24? There's like a little formula. sort of a formula for the
Divided by
period.
2b
Yeah.
or
Formula.
divide 2p.
That's exactly right. So the
2 pi
period
over-
is equal to, is it 2 pi over b? I'm not looking at my note sheet. Is that what it was? Or is it the other way around? Is it b over
Yeah.
2?
Yes.
It's that.
So either that, and I actually don't remember the way your note sheet's structured, but could you do the algebra to fix that yourself? Like what if you wanted to solve that for b? Couldn't you solve that for b? That's not hard to do. Multiply b up to this side and divide by period. So 2 pi over the period. Both of those formulas are true. And so effectively, this is the one I want. In other words, I need to know the B. The B is actually what you put in the equation, but you don't get to put the 24-hour period directly into the equation. You got to modify it. So since our period is 24, then I got 2 pi over 24 or pi over 12. That's my B value. So and that's extremely practical because the period of a normal sine wave is 2 pi. And in the real world, that never happens. Like 6.28, why would that be the time when something changes? Now, I just have to decide, you tell me if I let you pick, would you say this easier to call this a sine wave or a cosine wave?
I put cosine because that made more sense with where we had to shift it.
Yeah.
Negative cosine.
Remember the basic graph. Sine looks like this. That's what a sine graph looks like. In other words, at 0, 0, that's like right in the middle. That's where sine starts. Would you agree that point has moved to here? And I don't know where that is right now. Now, could I figure it out? Yes, because it's halfway between 2 and 14, halfway between 2 and 14. What is that, 8? I think that's at 8. So I can figure it out. But I already know where the top is. The top's right there. And that's how cosine works. Cosine actually looks like this. So cosine is it's right on the y-axis. Again, is that stuck in your head from memorization? Remember, you got a graphing calculator, get it out and type sine of x and cosine of x, graph both of them, look at it. Even if you know that right now, you're not going to know it when I see you in calculus next year. So, can you get it for yourself? Side question, but can you also relate that to the unit circle? I mean, can you get these answers off the unit circle? My point is I know where that top is right there. And where is it for us? Well, hasn't it, since it used to be here, hasn't it effectively moved right 14 to land right there? Hasn't that what it's done? It's moved right 14. So from Math 111, notice you can't choose the phase shift or how far to slide something until you decide, is it a sine or a cosine wave? Now that I decided it's a cosine wave, then I can say, oh, it moved right 14. So then I can come back here and say, okay, it's cosine, but how do you move it right 14? What do you do with 14?
Subtract.
Yeah,
Subtract it from x.
it's the opposite. So I think I got it. Notice I said I think I got it. I'm not sure I got it till I graph it.
I had negative 24 cosine and then x minus 2, which seemed to give me the same graph.
So think
I
about,
started with the 2 a.m. I took what was 14 and then switched it over.
I want you to think about what Nicola just said, because it's kind of cool. What does it take to flip a graph upside down? What do you got to do to it?
Negative of the amplitude.
Yeah, if you just make it negative. But again, think about why that is. If I said y equals just the cosine of x, if you make it negative, aren't you just making all the y values that used to be positive negative? Do you see why that would flip it upside down? And like, that isn't something you just have to memorize. So what he is saying, what Nicholas is saying, oops, that's not what I wanted to do. What Nicholas is saying is, hey, if I flip this thing upside down, Come on, man, focus. If I flip this thing upside down, then it only moved right too. Do you agree with that? So he's saying, and again, this is just, he's just making it harder. The easiest thing what I just did is probably the easiest. But what he's saying is, if I flip this thing upside down, well, first of all, would you agree the amplitude doesn't change? It's still 24. It's still going 24 above calm seas and 24 below calm seas. And the period doesn't change if you flip something upside down, and it still slides up 64. Like everything else stays exactly the same, except for if you flip it upside down, it only has to slide right 2 now. He's exactly right. That's another way to say the exact same thing. He's not wrong. So if you're free to choose, I'd pick cosine just because it's easier to define where the top went than the middle. But again, just to slow down a hair, do you agree that this point right here is going to be halfway between 2 and 14? It's like right in the middle, isn't it? Well, I can figure out what number is between 2 and 14. It's 8. So if that's true, again, only if you like pain, but would you agree that it'd also be true, if I switch to green, that the amplitude wouldn't change if I decided to do this with sine? Neither would the period change. Neither would the vertical shift change. Those are all exactly the same, except because sine is defined by, well, that kind of transition from concave up to concave down, and that went right 8. Then I could use sine if I wanted and say it slid right 8. Like all 3 of those are true. I think cosine's easier. But if I graphed all those through all 3 of those, I should see the same graph all lying right on top of each other. Now, if you're a crazy person, why would this also be the same?
It's just shifted 24 to the right. It's
Yeah.
the same line. It's just further down.
Since the period of this graph, it repeats itself every 24 hours, then didn't I just slide it down to land back on itself again? I'd be dumb to do that, but like there's actually hundreds, thousands of graphs you could make for this. I'm not going to do that unless somebody makes me, but it's just, all I'm trying to illustrate is like, you can think, you can reason about this. You don't have to create, a 9-step process out of this. But you got to draw a picture, I think. I mean, I have to. I'm good at this stuff. So I got to draw a picture of it. If they describe it to me in words, which is what that problem is going to do, describes a high temperature and a low temperature. It's like, I got to sketch a picture of that so I can kind of figure out what's going on. Just to give you time to process. Do you use Desmos at all? Has Matt showed you guys Desmos?
No, I shelled out the $150 for a calculator.
Well, they both have their merits, but
Had one for years.
Desmos is amazing because it's got color to it. So if you have played with it, or in the course of me teaching you things, if you find yourself liking it, you're welcome to use this on a test too. It's just a graphing calculator. So let's see. I just want to graph what I think we just said the answer was, and I'm going to pick the easiest one. And by the way, you can type the word cosine, C-O-S. And I'm going to do something wrong, and I want to see if you can tell me what it is. We said slide it right 14, and then add 64, if I remember right. Now, why don't I see the graph?
No parentheses. It's not written as if the pi over 12 is factored out.
Yeah, let's go ahead and fix that now. You definitely need the pi over 12 factored out, so I'm going to go fix that right now. But still, the question remains, how come I don't see the graph?
Because it's up at 6.
It's your window.
Yeah,
You only go up to like 10, but it's up like 64.
Yeah, think like where were the temperatures? They were at 40s and 64s, and look at my Y values. They're only from 0 to 10, so of course I don't see it. Ah, there it is. So, check your work. Like, you should not get this wrong and not know it. If you get this problem wrong on a test and you don't say, I know this is wrong, then you're going to get no points, because like you should know that it isn't working or that it is. I also love like smack talking notes, like don't even grade this. This is the key. Like I checked it on, I try to get my students to say checked in Desmos on there, just because that's what's going to happen in the real world. Like no one's ever going to pay you to know this stuff for some application if somebody else has to check your work. Does that make sense? They're going to pay you because you can stamp it and say, I give a lot of my plans to engineers for stem walls that are, afraid are going to tip over because of the dirt pushed against them. Like they're the final one. They're the one that's got to check this stuff. If they get it wrong, then they're either out of business, people die, or they get sued because the whole house falls over. Like, can you see that this is working? Let's go out there to X equals 14. Look at that. Hour 14, 2 p.m. It's 88 degrees. Cool. That looks right. Let's see what happens if I go 24 hours later. X 14 plus 24 is 38. Look at that. Same exact spot. Can you see that the period of that really is 24? The high temperature is really at hour 2 p.m. Notice 2 p.m. was a little tricky. If somebody said on a test 2 p.m. and not 14 p.m., you could get that wrong because that'd be 2 a.m. if you just thought of it as a 2. So 2 p.m. is really 14 o'clock, right? If 0 is midnight, which would be common to do, I think. So it's like, okay, yeah, I got it right. I know I'm right now. Just for the fun of it, even though it won't be fun. Let's throw Nicholas's answer in there, which was flip it upside down, but only slide it right to, why can't I delete? Notice how the graph hasn't changed. It's still the same graph, still hits the same spot. So the second thing about this though, because keep in mind, if you see this in the newspaper and then you go make an equation for it, all you are is just a math nerd. But what can you do with this? The whole reason to do this is because now you have this cool equation, but what can you now do that you couldn't do before? I want to know if you know how to speak the language of algebra. What can I now do that I couldn't do before?
Plug an hour in for X and try to predict the temperature later.
Exactly. You own the temperature now. You can answer easy questions, which would be, okay, that's really cool, but I'd like to know what the temperature is at 10 a.m. Watch this function notation. This is kind of a cool way to do this. And this is one of the reasons Desmos is really cool. Instead of calling that y, if I call it f of x, which doesn't at the outset seem to make any difference, it's still just y, right? You just graphed it. But now I'm going to go down here and say, I'd like to know what the temperature is at hour 10. So I'm going to say, I'd like to graph the point when x is 10. And what do I do to get y if x is 10? Well, don't I have to plug 10 in for x into that nasty equation up there? Which of course I can do on my graphing calculator, right? But you can also just let the machinery do it. So now, thanks to the way I worded that, I'm just going to say f of 10. And if I turn label on, it even takes me there. Like this is the last algebra class you ever have to take. You're only 4 weeks away from people think you know this stuff from now on. And it's this kind of logic that actually hurts people in calculus because they kind of don't understand what algebra is and what it can do. So it's like, cool, I now know what time, I know a good prediction for what I think the temperature will be at 10 o'clock. It's going to be 76 degrees. It's kind of lucky, by the way, that came out exact. Actually, I have no idea why that came out exact. That seems really surprising. Actually, I'd like you to think about that for a second. Why did that come out exact?
I would assume it has to do with 2 a.m. and 2 p.m. being exact times. And we used another exact time. 10 is a whole number.
Well, let's plug 10 into that. If you put, I'm gonna screen capture this. so I can write on it. So, side note, do you guys take a break? Can you do this for 2 hours straight? Obviously, just get up and go to the bathroom, or whatever, if you need to. But do you guys want to take a break for 5 or 10 minutes to kick your cat outside, or I don't care.
I mean, we typically just power through to the end.
Okay, that's fine with me. Feel free to, bail. Like, you're not hurting my feelings if you put your screen on. Again, I really appreciate when you show up face to face. It helps me when I see I feel like I'm teaching humans and not just talking to a machine, but also I can see your quizzical looks and, those kinds of things. It helps me do a better job. So let's just think about why that came out exactly right. Because I don't know about you, but when I take the cosine of something, I expect weird to happen, don't you? Like cosine of something, you get some horrific decimal, right? So, and again, I think you can see that this just happened accidentally. But again, I just wanted to teach you how to think. Like, why is that? That's interesting. I don't know. Let's go play around with it and see. Well, if I put 10 into that equation up there, and I'm gonna, let's go ahead and leave it alone. I was going to put it back to the way it was before, but let's see what happens if I put 10 in. Well, you end up with 10 minus 2, which is 8, right? So you get 8. I think I'm beginning to see it now. What do you end up taking the cosine of? What is that fraction if I simplify it?
Pi over 3?
Yeah,
No, wait.
close.
No, I'm stupid.
You're close.
That'd be 4.
I can simplify 8 over 12. What does it simplify to?
2 pi over 3.
Yeah. Now, again, what I told you before is true, which is I'm seeing 2 pi over 3 and I'm thinking, wasn't that one of the exact angles? Now, I don't remember which one. I don't have this memorized, but let's figure it out for ourselves. Let's reason this out from scratch. So in a sense, I got lucky and chose a location that came out perfectly right. But let's do something kind of cool. On a unit circle, this is easy. You don't need to memorize this. Since you go this direction, what do you call that location over there?
Pi?
Pi. Or 180 degrees, right? That's like the two names for it. If you're in degree mode, it's turning 180 degrees. If you're in radian mode, well, that's how you fix this. So instead of 2 times pi, if I said 2 times 180 divided by 3, let's see, 180 divided by 3 is 60. 60 times 2 is 120. So this is like the cosine of 120 degrees. And the only reason that's 64. How come none of you told me I'm dumb and can't write down the right problem?
None of us noticed it.
You're polite.
I thought it was a B.
That's what I thought when I looked at it. I was like, why is there a B there? I can't read my own writing. Now, can any of you answer this? I thought I told you earlier that the cosine only applies to right triangles. Why is that impossible to take the cosine of 120?
Because it's an angle above 180
Yeah.
or above 90.
Yeah. Like we already got 90 used up for the 90 in the right triangle. So the sum total of these two angles can only be 90. There's no way that's 120. So when you type this in your calculator, it should break. Your calculator should say loser, error, idiot, whatever. Why doesn't it do that? Why does it actually answer that question?
Because it's not counting from the origin, it's counting from pi over 2 or 90 degrees.
Yeah, like this is 0 right here, right? So 120 degrees actually lands you about right there, doesn't it? So
But that's still outside of the 90 degrees.
That's exactly right. But where's the right triangle? And again, this is things that I think are so important that I don't think students leave this understanding very well. There's the right triangle that this is referring to. And since this angle is 120 degrees, and if I had made it all the way, it'd be 180, then do you agree that this angle right here must be 60? So there is no such thing as the cosine of 120 degrees. It's referring to a triangle that's in the second quadrant. So I'm actually going back to things in chapter 5 to see how deeply you understood chapter 5.
Doesn't the negative on the front of it indicate that it's going to be in quadrant 2? Or am I thinking about it wrong?
No, you're exactly right. If you take the cosine of 120, you're going to get the same answer we're about to get. Well, I won't go all the way back to the end with this, but what you might remember about 60-degree triangles is if this length were 1, then this length would be double that. And then because of Pythagorean theorem, this would be the square root of 3. So what's cosine of that triangle? Well, isn't cosine adjacent over hypotenuse? Except for, as either Nicholas or Stephen pointed out. By the way, is it Stephen or Stefan?
Stephen.
Stephen. Because we're in that quadrant, does it make sense that one's got to be assigned to be a negative? So it turns out then that the cosine of 120 is negative 1/2. Like I didn't need to cheat and use my calculator to get that. Now keep in mind, most of what we know about math was done by people that had no calculators. Like most calculus books never have angles that aren't these exact angles because everybody in the history of math never had a calculator. In other words, they don't know what the cosine of 122 degrees is. They don't have a calculator to cheat to get the answer. So all the problems in calculus books are always like this happen to be. They come out perfect answers. Now, the cool thing is I was able to figure out it was negative 1/2. But if you looked at your cheater unit circle, wouldn't the coordinates of that point be negative 1/2? Well, let's see what sign. Isn't sign the square root of 3/2? Notice that's positive. This is what would be sitting on your unit circle if you cheated and looked it up, right? Notice I don't have it memorized, but I don't need to because I can make it for myself if I need to. So the cool thing about just getting your calculator out and saying what's the cosine of 120 is it takes care of the negative automatically. Does that make sense? 120 is in the second quadrant and x is negative in the second quadrant. So the 120 gives you the negative sign. Whereas what I just did, you got to assign the negative yourself. Like you got to draw the right triangle over there and just kind of know, oh, look, I went left. I went left and then I went up. So that means x would be negative and y would be positive. So all of a sudden I have the answer to my question now. That's why it came out exact, because the cosine of 120 is really negative 1/2. And if I take a negative 1/2 of negative 24, that suddenly turns into 12. And if I finish by adding it to 64, I get 76, which is kind of cool, right? Like in the end, I could have done this with my own mind. I didn't have to cheat and use a calculator, which was just dumb luck, right? But it's just kind of cool. Do you study all of your classes like that? Do you ever stop and just say, why did that happen? Or are you just trying to get it done all the time? I understand that. You got more to your life than math. This is probably your least.
It depends on the day, honestly.
Yeah. All I'm saying is, to the extent that you have time, don't lose that childlike wonder, just to say, why does that work? Or, why does that happen? Why did that work that way? Or, why does cosine work that way? Feel free to ask me those questions because I've probably thought about all of them. So that's just kind of cool. Interesting. So had I chosen any other number than 10, that probably wouldn't happen very often, right? Does that make sense? If I chose 11, it's not going to happen. This is the beauty of Desmos, though. Let's go back and choose 11. If I had chosen 11, I would have said it's 80.971 degrees, and I wouldn't have thought anything of it. I said, oh, it's about 81 degrees. So that's what's cool about finding this equation. It's not like, nerds in the newspaper. It's figuring out an equation so that then you can model anything you want.
And your Desmos is in radians, right?
Yeah, see that little wrench in the upper right-hand corner? I'm going to hit that wrench right now. default is radians in Desmos. If you don't mess with it, it's in radians. You can change it to degrees, but just like your calculator, you got to kind of be conscious of what mode you're in because that'll kind of screw you all up. So let me ask you a harder question then. So question, I guess I won't write it down. Question 2 is, what time will it be? Well, remember the low was 40. So if I said, what time will it be 38 degrees? That's never going to happen because that graph was never at 38 degrees.
Would you just write no solution?
Yeah, so only a mathematician would ask a question like that. But remember, you're also learning how to solve equations. And so let's ask a question that actually would happen. Let's say 48 degrees. Would you agree that then that's saying, oh, the time for 48 degrees, well, that means I'm plugging 48 in for Y. Oh no, this is very damaging to my person, you say. You are not wrong. I'm going to go back to the original equation because I think it was the easiest. Would you agree this equation also works for this? And would you also agree that's an interesting question somebody might want to ask? It isn't always just, I wonder what the temperature will be at 10.
X minus 14? Or did we change that to X minus 10?
That was dumb. I forgot. Thank you for pointing that out. No, it was 14, right? So I wrote it down wrong again.
Okay, thank you.
But again, to my point that I mentioned earlier, like if your work shows clearly and you did something dumb like that, and yet you did all the algebra that followed correctly, then I can still give you a whole bunch of points. And the only thing I just did wrong is I can't write my own problem down right. Doesn't mean I don't understand it, but I need to see some work. Now, so this is the second question algebra will answer for us, but it's just much harder. Before it was just order of operations. Like I can just type 10 in there and it tells me the answer. I don't really have to do that much. Can you solve this algebraically? Like that's what you're practicing right now. It's just not this ugly, but do you see the practical side of this? So I'd like to solve for X. Would you agree that X is buried very deeply in a lot of garbage? What should I get rid of first? Let's just do it.
I would get rid of the plus 64.
Yeah, let's get rid of that by doing the opposite. By the way, just a side note, most people don't know this, but isn't this the order of operations? You've memorized that or seen that before, right? That's the order that you do things in. Well, because we're trying to get rid of all that stuff, we're actually getting rid of it in the reverse order. So you actually look for additions and subtractions to get rid of first. So let's get rid of 64. Awesome. Let's see. My brain is in pain. What is that? 16? Negative 16?
Yeah, it's negative 16.
So success. Got rid of that. Next, I'm looking for multiplies and divides. Don't we have one of those? 24. So if I divide by 24, wouldn't that get rid of it? So far, this should just be like, yeah, easy algebra. I already know this, you should say. 16 over 24, I could turn that into a decimal. I do notice 8 goes into both of those, so I think I'll reduce it to 2/3. And I better write this a little more carefully. You are taking the cosine of all of that junk. Would you agree with that? Now you're in trig land. Ordinary algebra students can't do this. What do you get rid of next? Notice parentheses are last, so you can't get rid of anything in here. So the next thing is get rid of cosine. How do you get rid of cosine?
You can do the inverse of it.
Yeah.
On both sides.
It's not cosine times all that stuff. You don't get rid of cosine by dividing it. You get rid of it by the inverse. And that's why on your calculator, there's cosine and then second cosine. So your next move would be to take the inverse cosine of both sides. Do you agree with that? And now, maybe 2 over 3 like is striking me as like, is that an exact answer? Like, I'm not sure, but it was the square root of 3 over 2. This is not the square root of 3 over 2. We had 1/2, like this wasn't one of the exact ones. So this time I feel I didn't get lucky. I don't know if I want to call that lucky, but I'm going to type. I can't even see, it's dark at my house. Second cosine of negative 2 divided by 3. I got 2.3 approximately. So
Why is it negative for you?
why is it? Why is what negative?
Oh, never mind. You're doing your version. I had mine written down.
Got it.
Ignore.
Notice I said approximately equals. I'm telling you and myself that I just rounded that off. Now I got 2.3005, so that's pretty accurate, but I'm just telling everybody, hey, I just rounded this off close enough. We're talking about temperature. Do you actually need to know the exact second that it's 48 degrees? No, you don't. Now, do you also understand there's a ton of answers to this? Think about the unit circle for a second. Actually, think about the graph. Isn't there tons of times when that's at 48 degrees? So shouldn't there be tons of
Yeah,
answers to this?
but it depends on what day you're on. So I guess it wouldn't really matter because it presumably in this scenario, it would be 38 degrees at the same time each day.
Yeah, think about the unit circle. And again, I'm just interested in this. If you know that the cosine of some angle is negative 2/3, do you understand cosine is the x coordinate? Do you understand that that is -1? That's an x coordinate of -1. So wouldn't negative 2/3 be about right there? So that means there's an answer here and here. Do you understand what 2.3 is? 2.3 is an angle because you took the inverse cosine of 2 divided by 3. That's a couple of sides of a right triangle. So I got 2.3 radians. Do you agree that, oh, that must be that one right there? Because if I made it all the way to here, isn't that 3.14? And here is 1.57. So that must be giving me that answer right there. Isn't there lots of ways to rename that? Like 2.13 plus a full lap, isn't a full lap 6.28? So couldn't I also name that angle 8.41? Yep, and there's 1,000 other names for it. So that's where we're getting all the fact that there's hundreds of times when it's at 48 degrees. But then isn't there another one down here? Do you know what to call that one? Can you reason that out for yourself, or are you looking at book formulas? You should be able to totally reason this out for yourself.
I would assume negative 2.3.
Yeah, that's the easiest one. In other words, if you went here and it was positive 2.3, then wouldn't you just go there and it was negative 2.3? And again, you can add any number of 2 pi's to that you want to, right? So in the sheet that I just graded for you that Matt gave you, you could say the answer is negative 2.3 plus any number of 2 pi's that you want. 1 of them, 2 of them, 3 of them, 4 of them. There's thousands of answers to this. Now, if nobody makes me do otherwise, I'm just going to write down 2.3 and get on with it, right? So there's nothing wrong with what I did. I'm just pointing out, what if you had the question like, what's the last time in the day? Or what's the first time in the day it's 48 degrees? Or what's the last time in the day it's 48? You could be interested in a different point. Does that make sense? Quick side note, but in calculus, I have this cool mountain biking problem where the mountain biker jumps off of this and they land down here. If you land right there on your mountain bike jump, you're having a great day. You're loving it. Whereas if you jump and you land right there, you're hating it. And so in that project, you have to find different locations that have the exact same spot. And so we were using this for a calculus project in my class. There's kind of a hint. Don't sign up for my class, or you'll have to know this stuff. Well, you're home free now. Isn't that, this problem is now easy to solve. Would you agree that? It's not a trigonometry problem anymore. It's just basic algebra. So I would multiply both sides by 12 over pi, just because I want to finish this, just check it on the graph. So times
Divide.
12 divided by pi is 8.79 approximately, 8.79. And then all I got to do is add 14 to that. So then I'm done. Add 14. Notice it's 22 o'clock. X equals 22.8 o'clock. Like, don't forget what X meant. X was a time, right? It wasn't a temperature. It's not 22 degrees. 48 was degrees, and we just found out that happened at 22.8 o'clock. And notice that's like in the middle of the night. Does that make sense? So maybe that is an example of a time like, what good does that do me? If I want to like move my water when it's 48 degrees outside, I want to do it then. I want to do it some other time of the day. Let's just go back at the graph and look at that. So here's what I think is true. If I didn't screw this up, let's just check and see if I got this right. If I go to 22.8 o'clock as an approximation, why is this not pushing? And then I also figure out what that is as a Y value. Fail. Maybe I should just use my finger. Hey, look, it worked. Or did it? Did it work?
Yeah, that's close enough to 48 degrees.
Yeah,
I'd write that off.
that's why I like to write approximately equal, because I'm telling myself more than you. I'm telling myself I'm not going to get 48 for this. You can't in this case. We didn't get lucky and land right on an exact angle. So I'm going to get close. And of course, that's close enough, right? So it actually worked. So, you know, my question to you is what if I'd wanted one of those other times? Like, would you be able to pull that off? Would you have been able to find not the time kind of right before you went to bed, but isn't there another time over closer that would work too?
You'd have to look at it at a different time entirely, right? Other than 22.8
Yeah,
o'clock?
that's right. That's where you'd have to go back to what we did before and say, well, even though the calculator gave me the easy answer of 2.3, because of the math I ended up doing, I needed to use another time. Like maybe that negative 2.3 answer, maybe if I went back and did the math with negative 2.3, maybe that would work. Or maybe if I used 8.41, that would work. I mean, there's 1,000 answers, so it's kind of hard to know.
Would you not be able to take the time 22.8 o'clock and just subtract 12 hours from it?
You very well might be able to do that. Everybody understand why Madeline said that? Because that's a pretty good idea. Like the previous time that happened, isn't that half a period away from then? So since the period was 24, if I took 12 away, it won't surprise me if that's true. So that'd be 10.8. Just for the fun of it, even though it won't be fun, let's just quickly, if I chose to do this with negative 2.3, I'm just rewriting the equation that you saw above. Notice that when you multiply by 12 over pi, you're going to get 8.78 again. It's just, or 8.79 again. It's just that it'll be negative, won't it, instead of positive? So now when I add 14 to both sides, 14 minus 8.79 is 5.21. Honestly, I thought Madeline's idea was going to work, but I don't think it did. I don't think that was 12 hours before. I'll leave you to think about why that is, but apparently it was hour 5. Let's go see if that's actually true. 5.2. And I'm not kidding when I say my first instinct was, you're exactly right.
It wasn't on the midline, so that wouldn't actually be half a period away.
Nice job. That is exactly the answer. I completely agree. It wasn't on the midline. That's why that 12 trick didn't work. But notice 5.2 was an answer. See how I can check that? It works out. So the answer is stay in bed. 48 degrees is too cold. So 5 o'clock in the morning and at 10 o'clock at night, and you want to be out there anyway. In this one kind of practical problem, we hit all the stuff you're studying right now in one sense. It's like, why do you solve why are you solving trig equations? Again, I bet you didn't know you solved them because that's what the book said to do. But trig equations actually model things. And if they model things, then solving them sometimes happens. Now, again, does it happen for the average person? Like, go ask everybody you know, have you ever used this stuff? You're going to get no every single time. Like, you got to get in a pretty sophisticated place to actually do this. You agree with that? You got to be making a lot of money or doing something really complicated, if you will, to actually need this for something. But the way I like to explain it is, to people is there's a very good chance you won't need this if this is your last math class. But if you are working on a team of 6 people and something like this comes up and you can do it and no one else can, like, that's how you get raises and that's how you progress. And, it's cool if you're the person that can actually do something when no one else can. So I would encourage you not to look at it as, do I need this for anything I've ever done? No. Well, then I'm not going to pay attention. I'm just going to try to get this over with. As I've said, in my own case, just as a human being, I've made more money doing construction on the side than I've made in all the years I've taught combined. And I've used math that I know a ton in that environment. And I didn't know I was ever going to do that. I didn't know, that would be a part of my life. So just an interesting side note. How's your brain? Still got any room left in there? Is it in pain? I've got more where that came from. Let's do one other thing that's kind of hard, but again, I'm going to put you in my shoes for a second. I've got to make up something. I've got to make up a problem that's going to work right now. And what I want to do is make up a hard trig equation to solve, like one that's got not just cosine of an angle equals something, but I want to invent one of those ones that's squared, and that really doesn't come up very often. But I just want to let you in on, what a math teacher has to do to make up problems that work. And so I'm going to graph the equation. Let's see, y equals, how hard do I want to make this? Let's make it really realistic. This is maybe a terrible idea. Let's see. Sine of x, and I'm going to close that parenthesis and square it. Remember, out of laziness, and I'm going to check in just a minute. I'm not sure. Usually you put the squared between the sine and the x just because you don't want to have to write all those dumb parentheses down. Do you understand that? But this is what sine of x squared means. It means take the sine of x first and then square it later, not square x and then take the sine of it. There is an order of operations problem there. Let's see, plus, let's go minus 5 sine of x. And let's go minus, 3. So sweet, there's kind of a cool graph.
Why does it look like the top is more sharp than the bottom?
Yeah, this is not just a sine graph. Like, now that it's squared, you know what squaring does? It turns things into parabolas, right? So this is actually kind of like a parabola and a sine wave had some kids. That's kind of what's going on here. So the bottom of it kind of looks like a parabola, but the sine wave made it turn around. It's more complicated than just a sine wave is the simple answer to this. But now that I have this graph, does it make sense I could ask you, well, does it make sense I can't ask you to solve that if that whole thing was equal to, say, 5? Do you notice that graph never gets to y is 5? But it does get to y is, well, notice that it looks like it gets exactly to y is 4. That's kind of cool. It certainly gets to y is 1, 2, and 3. It gets to y is 0. Just to keep it simple, let's just let it be 0. So write that down real quick and just on a piece of scratch paper. So all that gobbledygook equals 0. So it's 2, -5, -3. We'll set it equal to 0. Maybe we'll get lucky with that. I'm going to bring this over for us to consider, and more importantly, because I'm going to forget what it is by the time I get over here. So the other reason I'm showing you this graph, besides the fact that I needed it to make a problem up like this, because if I'd randomly said equals 5, apparently that wouldn't have worked, is because I want to use the graph to check the work. And I want you to do the same thing when you're taking a test. You should not solve these problems and just kind of go, I hope I got that right. Like, you can check it yourself. So the way this problem would be written as a book assignment then would be something like 2 sine, and you put the squared there, minus 5 sine of x minus 3 equals 0. And by the way, if I'd chosen y to be, say, as I was about to do, if I'd chose y to be, say, 2 instead, what would you have had to do to start this problem? Since it's a squared equation, how do you solve squared equations?
You square root it.
Yeah, to solve squared equations, you're going to have to square root it. And ultimately, that's where the quadratic formula comes in, or factoring. Like, it's got to be equal to 0. So if I'd said equal to 2, you would have had to subtract 2 from both sides, in which case then this would have been minus 5 down here equals 0. And then you would have been on your way. Does that make sense? Which is what would happen, if you will, if this was a little bit more realistic. But I made it easy on us and just said it's 0. Can you agree that I can already estimate the answer right now? There's one of them. What do you think that is? There's 3, there's 3.5. I'm going to go with 3.65. I'm going to say 3.65. I'm guessing, right? And let's see, I have another one. Here's 5, there's 5.5. That looks exactly between 5.5 and 6. I'm going to call that 5.75. Those are my guesses. Notice I can steal, if all I needed was an approximation, I can actually steal this answer right off the graph and I'm done. I don't even have to do this. And in real life, that's all you usually need is an approximation. Whether it be in darkness or light. And there's a whole bunch of answers beyond that, right? There's thousands of answers to this, but at least there's a couple of them. Let's just go see if we can do the algebra for this ugly trig expression to answer this. Would you agree? You don't have to write this down, but would you agree it looks an awful lot like 2 times something squared? I'm just going to make my own letter up. Would you agree it looks like that? It's just that the m or whatever letter you're trying to solve for is just ugly. It's like the sign of x. What I'm hoping you still know from Math 95 and college algebra is, like, you have to use the quadratic formula to solve these. Or maybe you get lucky and you can solve it by factoring. I guess I'll try that really quick. That's the only way to solve squared equations. So let's see. 2 can only be 2 and 1. 3 can only be 3 and 1. So either the 3 goes here and the 1 goes here, or maybe I have it the other way. Does that work? Did I get lucky and it worked? Or do I get not lucky and it didn't work? Let's see, minus 3, that'd be minus 6. Oh, I actually think this works. That actually does factor. You can actually solve this by factoring. That was very miraculous considering I just made this up. I would tend to, and by the way, because this is a book assignment, typically they will solve by factoring, but I would tend to use the quadratic formula and just say m is equal to negative b, which makes that positive 5, plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. I don't want to sit there factoring something. It's like it's going to take me forever. It probably doesn't factor anyway. If I did do that, let's see, that becomes 8. That becomes 25 plus 24, doesn't it? Oh, no wonder it worked out perfectly. 25 plus 24 is 49. That happens to be a perfect square. So 5 plus or minus 7 over 4. So 5 plus 7 would be 12 over 4, which is 3. And 5 minus 7 would be negative 2 over 4, which is negative 1/2. Isn't that the same answer as I get up here? M is 3, M is negative 1/2. It's the same answers, right? So if you speak the language of algebra, you should know that solving squared equations is not cool. Like you either factor because some nerd made the problem up or got lucky like I did, or both. I'm a lucky nerd. But in the real world, that's never going to happen. You're going to get decimal answers to this. Now, if this was just 2m squared minus 5m minus 3 equals 0, you'd be done. You'd say m is -1/2 and m is 3. Those both work. It's just that in our case, that wasn't m. It was the sine of x. And so we've got the sine of x that is equal to 3. And the sine of x is equal to -1/2. This 3 right here, is that sides of a right triangle or is it an angle?
My first assumption would be a side of a right triangle.
I'll just ask you this
That's an angle.
rhetorically, but how much would you bet?
Perfect.
If I gave you $100, would you bet at all that you're right as you pick one or the other? Or would you say, I'll just keep the 100, I'm not going to bet at all?
I'll just keep the 100.
If you're taking the sine of it, it's an angle, which means that is an angle. When you take the sine of an angle, it's sides of a triangle. So this is sides of a triangle. That's 3/1 in a right triangle. Again, that's very much in disguise here because it's not a fraction. If that had been 3/4, then none of you would have said it was an angle because you would have said, oh, two sides, look. Remember, that's still a fraction. So this is referring to a right triangle where this is angle x, and since sine is opposite over hypotenuse, that's what that triangle looks like. Like this is what this is referring to. What's wrong with this picture? What's wrong with that triangle?
The hypotenuse is the smaller number.
Yeah, the hypotenuse is not the biggest side. Therefore, when I bust out my calculator and say, I'm going to solve for x by going the inverse sine of 3, what's going to happen?
It's gonna give you an error.
It's going to go boom. It's not going to work. You can type it in if you want to, but you should be able to reason about this a little better than just type it in. The other part of it is remember on the unit circle, sine is the y coordinate. So can you ever have a y coordinate that's 3? No, the biggest one you can have is right there. It's 1. The sine of an angle can never be more than 1. So there is no x. There is no angle. This is not going to work. There's no answers because of that. So good. Less for me to do. Nothing. This one, however.
So does that mean that the correct answer is -1/2?
Yeah, now this one's gonna work because is there a right triangle where the sides are 1 and 2? 1 is the opposite and 2 is the hypotenuse. Yes, there is. Not only that, but we even got luckier. You should recognize this one. You should say, oh, unit circle. There is a y coordinate on the unit circle, and we'll watch this. Where is there a y coordinate that's -1/2? Well, isn't this right there? Isn't that -1/2 since that's the one? So there's 2 places you should be looking on your unit circle. One of them is right there, and one of them is right there. And what are you going to see? You're going to see an ordered pair where the y coordinate, because sine is y coordinate, is -1/2. Isn't that what you're going to see in both those locations? Therefore, there's an exact answer to this, which is, again, who cares? Just hit inverse sine on your calculator and write the dumb answer down. But it's just kind of cool. So if you guys are looking at your sheet, then what's the name for that location right there? What is your, I don't have this memorized. I don't know. It's like 2π/3 or 5π/6 or something like that. What is it?
7π/6.
7π/6. That looks reasonable. because 6 pi over 6 would be 180 degrees, which would get me to here, and that's one a little bit past that. So I think that's right. I don't know, was that Aaron that said that? Now, based on the fact that that's pi over 6 past this one, I can now reason the other one out for myself, because this would be pi over 6 short of 2 pi. In other words, 2 pi minus pi over 6. So 12 pi over 6 minus, that'd be 11 pi over 6. So the other one is 11 pi over 6. You guys are looking at your sheet, so you should just be able to see that. But it's like, can you think like that? Can you reason for yourself? Those are in the same exact location. So there's actually two answers inside the 0 to 2 pi range. Now let's go back to our graph. So is that the answers we just got? What is 7 pi over 6 as a decimal? Because I want to check my work. Like,
Yeah,
nothing-
3.67.
So this is, let's change colors. Is that what you're saying? This is 3.67. That sounds reasonable.
Yes.
What's 11 pi over 6?
It's
5.6.
5.76.
Yeah,
7.6. So does that agree? Yeah. So check your work. Notice my guesses were pretty reasonable. But again, I don't know about you, but even if I had cheated on the graphing calculator and asked it the coordinate of that point, I would not have recognized it. Desmos is really cool because you can actually go to those points and it kind of knows you might want them. So you can just like poke at them and they'll show up. Whereas your graphing calculator, you got to go calculate and find the 0 and all that nonsense. Notice, I didn't know it was going to do this. It actually gave us exact answers to that. I didn't think it would. I was expecting decimals, which is why I went there, but whoa, it gave us exact answers.
so Desmos cheats, is what we know.
Yeah, it cheats better. I'm totally surprised by that, by the way. But again, notice there's all these other answers out here. Because remember, there's more than one way to name those two locations. 7 pi over 6 and 11 pi over 6. If you do multiple laps, you can rename them the same thing. So there's technically thousands of answers to this. For the test next week, I am not going, or Friday, I'm not going to ask you for all of them. The plus 2k pi thing. I'm just going to say, give me all the answers inside one lap around the unit circle. Like, do it based on logic. Do it based on the picture that I just drew. Can you draw that picture to see both of those answers? Again, we just got lucky that we didn't have to push calculator buttons. You should just go inverse sine of -1/2, get some weird decimal and write it down. You're done. Good job. The question is, do you understand that's radians, and can you kind of picture where that would be? If I just, and I'm going to do this on my calculator right now. If I say, I'm in radian mode, can't see. If I say second sine, inverse sine of -0.5, my calculator says -0.52. I'll just round it off to that. The question is, can you look at that and look at the unit circle and go, yeah, that makes sense. That seems reasonable. This is why it's so important what I told you earlier. Do you understand that that is an angle? If you take the inverse sine of it, then this is sides of a triangle. That's an angle. In radian mode, angles look weird. So my point is, could you go to the unit circle and say, oh, negative, huh? So we're going that way? We're going backwards. And the only places I have memorized, I don't know about you, but are these high points here. Like, isn't that 1.57? Do you have that memorized? That's pi over 2. I have that memorized. That's 1.57 is the 90 of radian world. Like a 90 degrees is 1.57. So if I'm only turning 0.52, then wouldn't that be like a third of the way along that? So wouldn't that be about there? Do you agree with that? And then if I look at that, then I think to myself, well, look at that. That's a y value of negative 1/2, just like it was supposed to be. That's probably right. You should spend a decent chunk of your time making sense of this stuff, not just pushing buttons. And I say that because I graduated from college with a math degree, pushing buttons and got all the problems right, and got a A- average in my math classes, but I didn't understand one thing. Like I get the problems right, but I didn't understand how easy the stuff was, or I didn't understand I could make sense of it. And so you're just taking this to, because you're trying to get to a degree, and probably it isn't, you're not going to probably do tons of math in that degree, most likely. But to whatever extent you can, spend some time making sense of it, because this stuff can become easy. I was on the phone to somebody for a half an hour before I met with you guys, and I haven't taught this class for like 3 years. And so I did zero prep, and I haven't taught it for 3 years. So, why am I able to just explain this stuff off the cuff like this? Well, it's because I understand it, not because I have it memorized. I have a terrible memory, but it's because it makes sense. So spend some of your time getting past the steps and the confusion, and that might take my help sometimes, but ask those questions, like, why did that happen? Ask those questions during class. I give you permission to just interrupt. Don't raise your hand, because I'm going to be looking down and I'm going to see. Just interrupt and start talking. Hey, wait a second, why is that like that? Or correct me, because I can't write the problem down wrong.
So why is 1.57 the 90 degrees of radian world?
Because we agreed that pi is 180, and so if I divide that by 2 to get 90, because I speak degrees, then I'd be dividing this by 2. And so if I take 3.14 and I divide by 2, I get that. And so I just memorized that. So I have memorized, going the positive way, I've memorized that that's 1.57. If I make it to here, that's 3.14. If I make it to here, that's either negative 1.57, or I think it's 4.71. Like I said, it's been a while since I taught this. 4.71. Yeah, that's right. I just added these two together. So that's 4.71. So if I get an answer that's like 5 radians for an answer to something, which again doesn't mean a lot to me, I just think, oh, 4.71. Oh, it's a little past that. So it's over there in the 4th quadrant. Like I kind of know where I am. Just like if I'm sitting in my chair and I say turn, 80 degrees. Well, I kind of know what that feels like. I can turn 80 degrees and then, start hiking in the woods or something, but I can't turn 5 radians. Like I got to draw a picture of that. It's not my native language, even though I've taught this for a long time. But because I know the benchmarks of 1.57, 3.14, 4.71, and either 0 or 6.28, then I know about where 4 radians is. I know about where 3 radians is. I know about where 2 radians is. And so I at least have a feel for what those mean, but I kind of have to convert them. Just like people when they're learning foreign language, if you learn a word in Spanish, you probably have to convert it to English before you can know what it is. You can't just think in Spanish. You got to practice way more to think. I still don't think in radians.
Question.
Go ahead.
So how did you get like the 0.52, and like why is it so different from the other two, like the 3.67 and 5.76?
Yeah, that's because that's a great question. So I thought this is Kaylee. Am I pronouncing it right, Kaylee?
Yeah.
Kaylee's like, what's the deal? Like that wasn't one of our answers. I got negative 0.52 when I typed it in my calculator. Can somebody solve that mystery? Why is that the case? Why?
Would that be the point on the graph that's just behind 0?
So because the calculator happened to give me this answer right here, isn't there more than one way to name that? So if I went this way, since this is 6.28, if I took 6.28 and I think of it as, oh, I was on my way to 6.28, but I had to stop 0.52 short. 12 minus 5 is 7. So that's another name for the same location. So, you know, it's better to call something positive probably. And so that's why that just didn't show up on the graph. But I would like to point out that there's negative 0.52 right there. Still an answer. And notice it's exactly 1 period away from that. That's why they're the same exact answer. It's the same exact location. It's like you're coming down, you're skiing downhill right there, and you're skiing down right here. Those are the same exact location. It's two ways of saying the same thing. Awesome question.
So the calculator just gave you the negative 5.2 or the negative 0.52 because it's the closest to the 0 on the graph.
That's exactly right. The calculator will give you basically, when you take inverse cosine, it's going to give you the answers over here on the right side where the numbers are really small. And for sine, it's going to give you the numbers up here on the top. It'll give you those two, I think. So yeah, the calculator just might not give you the one you want, but your ability to change it to something else is kind of the key. In a sense, what we've done tonight is kind of, I don't know, teach you how to think a little bit. You know, Matt's really good at that too, but he has his own way of looking at it, and I have my way of looking at it. So between both of our explanations for this, that's really good. But in a sense, we covered some of the harder parts of 6.5 and 7.1. So what I want to do Wednesday is again, what would use your time the best Wednesday is if you looked at those review questions, and you know, any of those you had trouble with, like you lead the class Wednesday and say, hey, can you give us another one like number 7 because that one destroyed my soul or whatever, and then we'll do that. Or I can mess with this question a little bit as Matt did on the take home questions he gave you. And like, what if there wasn't just two signs there, but what if one of them was like tangent? What if there was tangent and sine in the same problem? That's not good. It'd be kind of like, I don't do that now, but you know, I'll mess with that a little bit, but I don't want to go too far down that road. Cause again, I'm not going to give you the hardest test questions. The things that I gave you today are all things I would give you on the test. And in one respect, at least for the stuff that you've done most recently, like we reviewed a ton of things just that'll make you do well at the test on Friday. So I'll throw a few more things out there on Wednesday, but as I said, the best thing you could do is come with things that are bugging you, and then we'll let your questions lead the discussion. So 7:20, get yourself out of here, but stay after if you want to. I'm gonna post everything I just wrote. As I told you before, I'll post that in the file that I made. And then I'll also, as soon as the video, you know, records itself, then I'll get that on YouTube and post a link in there too. So in the unlikely event that you want to re-listen to this brilliant lecture, that you can listen to it all again, or maybe share it with your friends, or get no likes on Facebook by sharing it with your Facebook friends. Make your friends hate you.
Trying to make a YouTube career here, I see.
No, nobody's going to get famous listening to math.
Khan Academy did. They started on YouTube.
He's already got it right. The only way you can do math videos is if you keep them to like 5 minutes and you just do one problem and then you turn it off. If you have like a 2-hour deal like I just did, not good. You don't want that. Everybody good?
Yes, thank you.
Thank you.
Also, this is my dog Phoebe. She decided to come learn math today.
That's good. He seems happy. He seems happier than all of you for some reason. Wonder why.
Our dogs do not understand math.
Yeah, they don't need to.
Bye, you guys.
Bye.
Nice to meet y'all.
Thank you.
Nice
Bye.
to meet
I
you.
did
Thank
have,
you.
like, a little thing.
Thank you.
Mr. Gardner.
Yeah.
So with the take home thing, I had forgotten that it needed to be submitted because we had done it in class. And so I used a late pass and put it back in.
Oh, okay,
So I
good.
just wanted to let you know because you had written like no submission.
Yeah. I just had a couple people that didn't turn it in. I wasn't sure if they were engaged or whatever. I'm glad you told me that because I'll go in there and scope it.
Yeah.
So were you able to submit it in My Open Math like where it belongs?
Yeah, I just used a couple of late passes because I hadn't used them.
Okay, good.
And so,
I'm gonna go look at that really quick just since you said that and just make sure it's in there.
alrighty.
Might as well, right? Where am I? Solving quiz, grades, grade. But bam, there it is. Got it. Yeah.
Alrighty. See you Wednesday.
Okay, see you Wednesday.
I have a question.
Fire away.
Hi. So I discussed this with Hagen before he left
Okay.
about testing accommodations. I don't know if I have to discuss that with you now or do I just kind of
Just give me the
am I
quick explanation of what your accommodations are.
it's just extra time testing.
How much?
It just depends on the teacher, I guess. I never tried to be greedy with it. I've used that with my last math class before COVID and it really helped, or
Yeah.
at least to me at least.
Yeah. Well, you've got something from. Do you have something on record about that? Because usually they'll tell me it's like 1.5 times. So if it's like an hour test, then you get
Well,
an hour and a half.
Hog-
It's 2 times, and so if it's 2-hour test, then you get 4 hours, and so.
well, Hagen gets a confidential email about that regarding to me and like, my disability, I guess. And it was an email sent out to him and my
Yeah.
other teachers. But I don't, since you're subbing for him, I don't think that email would go to you since
No. I believe you. Just tell me what it is. Like you don't have to tell me what the reason is, but do they give you 2 times double time on the test or time and a half? That's the 2 I usually see.
I think 2 times.
Okay, yeah. And that test is
If that's
open
fine.
from 8 a.m. on Friday till like midnight. So just take 2 hours.
No, yeah, of course. Yeah, no, I just extra time really allows me to be best. I like from the last test, I knew how to do a question, but I didn't have time for it. And
Okay, yeah.
that was really unfortunate, but I still did it and I turned it in and I still got partial credit for it. But
Yeah, and I would ask you to just be honest about that. Like if you have 2 hours and you run out of time, then turn it in with the last problem not done, but then go ahead and finish the last problem and say, just tell me like I did this after time, but I do know how to do it. And then yeah, absolutely. Cause then I can get
and that's what I did. And like for the review, are you basing the test off like the review and homeworks? Because I always get confused with that with teachers. With Hagen, it seemed like it was homework and review because when I did the review for the first test, I did it all. Actually, almost all. I did it all, and I realized when I did the test there was one question that was not on the review and it was only mentioned once in the homework and I got really frustrated and I took so much time on that it took away from me doing 2 problems.
Yeah,
And
I would
it's
advise
just
you
stressful.
just based on test taking skills. I think there's an argument for teachers to give one problem, like to get an A, you've got to be able to, think and really apply this to something. I think that's fair if the teacher kind of goes down that road. But
Right.
when you're taking a test, and I'm taking this class over, so I didn't set it up for myself. So I'm going to try to leave it alone as much as I can to not screw you guys up and make you adapt to some new teacher. But I'm just going to pick the problems out of your assignments and because it's coming out of My Open Math, so it's coming out of your assignments. But the only thing I would say is like if you run across a problem that you just look at it and you think I'm not really sure how to do that, immediately skip it. Like go on and make sure you get done everything that you feel really good about, and then go back and tackle those. Because it could be that problem, maybe that is that problem that separates kind of A from B. Or maybe you just didn't know it very well. Maybe it wasn't one of the hard ones, but you just didn't study it very much, or didn't never felt that
Yeah.
whatever. Well, then skip it. Come back to it later.
Yeah, no, I didn't. I only saw it one time in the homework, and then and it was really hard. I remember doing on the homework, and then it didn't show for the review, so I didn't think much of it until when I did the test. I was like, oh crap, I remember this problem.
Yeah.
And it was shown, and but I mean, I get what you mean. I really I do the review and then I do the homeworks as much as I can, even if they're past the due date and I didn't do, like, let's say 2 or something, I still do them just so I know.
Yeah, good for you. It looks like, I mean, I've got to fix his grade book because he's got 10% of your grade coming from that take-home assignment, which isn't fair. And his My Open Math doesn't match what's in the syllabus. So, but even with that being the way it is, like you're right there getting a B. So it sounds like you're working hard and doing okay.
I'm trying really hard to get the B. It's the one that's I guess the first test and the homework, I guess. And then that take home quiz, that one really threw me off because I had no idea which chapter it was from. Well, I mean, I did it, but like I just it didn't look familiar to the homework because I always base off everything off the homework or the review.
Yeah, sure.
And when I did the quiz, I was like, wait, where's this from? And some of it was even new to me. I was like, oh, this is interesting.
Well, that's why I was a little confused about when I showed up tonight, like where you guys actually were, because those questions, the harder parts of those questions were from the